Welcome back. MEFB 2013 manufacturing processes. Okay, so in the last class we spoke about composites and we completed nature and properties of materials. So remember that the most important element in a manufacturing process is the material selection. Yeah, so if you select the wrong material, you will end up getting a failed product despite having a very aesthetic design or a high quality product. Okay, so now let's start looking at the different manufacturing processes that is available. The first one that we're going to talk about is foundry process or sand casting process. Yeah, so what is foundry process? Okay, so foundry is a process of producing metal castings. So you're going to produce a part using casting method. Okay, what is casting? You're going to use a mold, H1, to produce your part, and your part is obviously made out of metal. So foundry process consists of four. First of all, making molds. So you need to make a mold. Okay, you need to make a mold in order for you to pour in the liquid metal. So it's just imagine yourself at home and you're trying to make jelly. Okay, so how do you make jelly? First of all, you need to melt the jelly, right? You melt the jelly, you add some coloring, you add sugar, and you are going to pour it into individual molds, each one, right? Once you pour it into the individual mold, you have your mold, you let it cool down and set, and then you're going to put it into the fridge. After several hours, you take it out of the fridge and you eject the jelly. The jelly would have followed the shape of the mold, and you have your final finished product. Having the same concept in mind, now you're going to do casting, in specific sand casting, whereby the mold is now constructed from sand, in specific silica sand. And once you construct the mold, you have your particular shape. Once you already construct the mold, you put in the pattern to create the shape, and you already have the shape. Then you're going to melt the metal and pour the metal to fill up that empty cavity or the empty mold and allow the metal to solidify. So in the foundry process, it consists of number one, you make mold. Number two, you are going to melt the metal. Number three, you're going to pour liquid metal into the mold. And lastly, once the metal has solidified, you're going to eject the part. The part will be called a casting now, and you're going to clean the casting. So this is typically a mold. Okay, so if you look at it, yeah, we'll talk about it in a more detailed manner, but for your knowledge, if you look at it, there's two halves to the mold. Yeah, there's two halves to the mold. You have the cope half and the drag half. Typically, this construction is called removable pattern, because in this construction, you're going to construct the cope separately, the drag separately, and half of the pattern or the metal or half of the pattern, or we call it a wood pattern, will go into the cope, and the other half will go into the drag. And then when you combine it together, you would get a complete mold structure. Okay, so we'll talk about that further. So basically, once you have created the mold, just before the pouring process or just before you pour in the liquid metal, once you already have the pattern ready, you need to remove the wood pattern, and you already have that fully shaped part. And this is how you're going to melt the metal in a so-called furnace. We call this a furnace. And you are going to manually transfer the liquid metal into a ladle, and from the ladle it will be transferred into the mold cavity. Okay, so again, what is a casting? Your final finished product is called a casting. Okay, you will not call it a part, but you'll call it a casting. Casting processes are required to approach the required shape of the part. So you need to, in order to obtain that particular shape, you need to use this casting technique. Casting is an operation of shaping metal by pouring it into the liquid state into a mold, followed by solidification. So once you pour the liquid metal into the mold, it will be followed by solidification. Okay, so classification of molds. So you have different types of molds, yeah. So in sand casting, we're going to specifically talk about construction of a sand mold. But besides a sand mold, you have other things like metal molds. We'll look at metal molds in the next chapter, yeah, contemporary or modern casting. You have plaster molds. We're not going to talk about that in this class. And ceramic molds, okay. So there's several types of molds that are available. Okay, so let's look at the sand casting and molding procedure. So sand casting are very famous because of their economic advantages. Sand mold produce cheap casting. Why? Because your mold itself is constructed out of sand, and not any sand, it is silica sand, typically similar to beach sand. So if you look at it, sand is readily available, very cheap. You can get it for free at no cost, yeah. So your task is basically, you need to be a professional to actually construct the mold well from the silica sand. And if you have got it right, if you constructed the mold well, your other cost would be the wood pattern, okay, which is very minimal, the pattern which is made out of wood. And lastly would be the metal itself, where you're going to melt it and pour it into the mold cavity. But besides that, there are no other hidden costs when you're using a sand casting as a manufacturing technique. Okay, so in the category of sand casting, okay, in the category of sand casting comes with two types of pattern. You can either use a removable pattern, just like the one I showed you just now, yeah. A removable pattern. So this is a removable pattern. So you have your pattern made out of wood. Okay, half of the pattern goes into the cope, half goes into the drag. Just before the pouring process, while you put in the pattern, you're going to put the pattern there and you're going to ram the sand around it. So this is the cope half and the drag half. You're going to ram the sand surrounding the pattern, and then you're going to overturn the cope onto the drag. And the dimensional accuracy is very important to ensure that when you overturn the cope onto the drag, it will fall typically symmetrical with the bottom pattern. Okay, so therefore, just before you pour in the liquid metal, so right now once you have compacted the sand around the pattern, the sand is going to follow the shape of the pattern. And before you pour in the liquid metal, or we call it technically molten metal, you need to remove this pattern because you do not want to damage this pattern. You want to keep reusing this pattern over and over again. So you need to remove this pattern, and when you remove the pattern, the shape of this pattern has already been embedded in the sand. Same thing in this is the drag half. In the cope half, the shape of the pattern has embedded in the sand. So now when you terbalikkan, or you overturn the cope onto the drag, and if your dimensional is accurate, you will find that it will fall exactly symmetrical. Okay, so this is the top half and this is the bottom half. So when you terbalikkan the cope onto the drag, or you overturn the cope onto the drag, you should get an empty cavity in this shape. Okay, an empty cavity in this shape. So that empty cavity is the one that's going to be filled up with molten metal. Okay, so like I mentioned to you earlier, classification of molds, you have sand mold, metal mold, plaster mold, and ceramic mold. So obviously in this chapter, we're going to talk about sand mold, in particular silica sand mold. Okay, so like I mentioned to you, there are two types of pattern, the removable pattern and the disposable pattern. When do you use a removable pattern and when do you use a disposable pattern, first of all? So if you look at the removable pattern, okay, removable pattern is when sand is packed around the pattern, like I just showed you. Yeah, after that a cavity will be formed by removing the pattern. The molten metal is poured into the cavity. So if you look at here, this is your cope and drag, and this is your pattern here. Yeah, when you remove the pattern, you'll be left with an empty cavity, ruang kosong, empty cavity that has followed the shape of the pattern. So you're going to do this to the cope and to the drag to get a symmetrical pattern, because half of your pattern will go into the cope and half of the pattern will go into the drag, and that's when you overturn the cope onto the drag. But before that, you need to remove the pattern slowly. If you have compacted the sand very well, when you're removing the pattern, your sand will be all intact, so you won't have any disturbance in the sand, and the shape will be all intact. So you're left with a void or ruang kosong, which will be filled by liquid metal. Okay, so sand is packed around the pattern. After that, a cavity will be formed by removing the pattern. The molten metal is poured into the cavity. Okay, so as I told you, for removable pattern, the pattern is made out of wood. Why out of wood? Because wood is inexpensive and you can easily carve it or shape it. But the most important criteria is the pattern has to be symmetrical, so that half of the pattern will go into the cope and half of it will go into the drag. And patterns are coated with varnish to create good smooth surfaces. And in case of mass production, metal patterns are used. So if you want to use wood pattern, it is only for small scale production, 50 parts, maximum 100 parts. Because when you use a removable pattern, you need to reconstruct the sand mold over and over again, because every time the casting has solidified and you want to remove the casting, you need to break open the mold. Okay, so when you break the sand shatters and the whole mold collapses. So for your second part, you can reuse the same wood pattern, but you need to construct the cope and drag again from scratch. So it is a very tedious process. Therefore, if you intend to produce 1,000 parts, 2,000 parts, okay, you cannot afford to use a sand mold because it's very tedious. Therefore, you must use an automated machine, which is a metal mold. Okay. Okay, so this is an example of a removable pattern. Yeah, example of removable pattern. So half of the pattern will go into the cope and half of it will go into the drag. Okay, so this is the parting line. If you see, there is a parting line here. Yeah, so this half will go into the cope and the other half on the other side will go into the drag. Okay, similarly here, yeah, you see there's a parting line here. So the top half of the pattern will go into the cope and the bottom half will go into the drag. Okay. Okay, so this is an example of a removable pattern. Okay, so how do you make a mold? Okay, making a mold is very tedious and it needs professionalism and lots of work. Yeah, so there's several steps involved in making of a removable pattern mold. So first of all, you need to construct the drag. As I told you, you're going to construct the drag separately, and you're going to construct the cope separately, and then you're going to overturn the cope onto the drag to form one simple structure. Okay, so first, making of the drag. The pattern or half the pattern, actually half of the pattern is placed on a molding sand and is rammed around the pattern. The sand is vibrated so that it will fall down on the pattern. The sand is then pressed and you do the same thing, and the drag is turned over and the gate to the cavity is formed. Okay, so here this is it. You've put in half the pattern, okay, and you are going to compact the sand around the pattern so that the sand will follow the shape of the pattern, so that later before the pouring process you can remove this pattern and the shape has already been formed on the sand. Okay. Okay, so this is typically the arrangement of a removable pattern. Okay, so you have your cope, this is your cope, this is your drag, okay, and then you have your pouring cup. Pouring cup is a location where the liquid metal flows in. So liquid metal, and then you have a riser. What's the function of the riser? Riser is to compensate for shrinkage. Okay, so then you have vent holes. You need a vent hole for trapped gases to escape. If you don't have vent holes and there is air or gases present, what's going to happen to the air or gas? It's going to travel back into the cavity and it will affect your casting. Okay, then you have something called a parting line. Okay, so if you look at that, you need the parting line, and at the parting line you're going to put some kind of powder. We call it a separation powder to prevent the cope and drag from sticking due to high heat. Okay, so like I mentioned to you, first of all, you're going to put in half of the pattern in the cope and half of the pattern in the drag. Okay, and just before the pouring process, you're going to open up the screw, open up the cope and drag, and then remove the pattern and then close up, so you have the empty cavity that is following the shape of the pattern. So this would be initially be the pattern there in the top half and another pattern in the bottom half. Just before and then you compact the sand around it. Just before the pouring process, you're going to open up that screw and remove the pattern slowly, but the shape will remain if you have constructed the mold well. If you have not constructed the mold well, what happens the moment you remove the pattern, the mold may collapse. Okay, what's the function of riser? Riser is to compensate for shrinkage. What do I mean? So when liquid metal comes in, how does it come in? It comes in through the pouring cup. So use the ladle and pour the liquid metal through the pouring cup. It flows down and it goes and fills up the riser. It will flow and fill up the cavity. But by this point in time, you've already removed the pattern. Yeah? So you're left with the empty cavity. Okay. So when it fills up the cavity, we allow it to solidify, and once we allow it to solidify, and the biggest challenge is during solidification process, because as you know, material characteristics, material either expand or shrink upon cooling. Yeah, so the moment it starts to cool down, the material may expand or shrink. If it expands, it's okay, but if it shrinks, then you need the riser will keep the liquid metal in the form of liquid for a very, very long time. So it will release the liquid metal to fill up the shrinkage, or to overcome or compensate for the shrinkage. Okay. Okay, so then you have sprues, runners. Okay, and this is obviously your mold in the typical sand casting process. Okay, so let me give you, before I end, let me give you a few terms here that you need to know. Number one, cope. Cope is the upper half of the mold. Number two, drag. Drag is the lower half of the mold. Okay, then you have gas vent. Vent is to allow trapped gases to escape. You have the riser. Riser is to compensate for shrinkage. Pouring cup is a medium through which liquid metal is transferred into the system manually. Okay, then you have a sprue, or a sprue pin is basically, initially you have a sprue being placed here during the construction of the cope and drag. What's the function of the sprue is to maintain the presence of this space. So once you've already compacted the sand all around, yeah, and the sand has followed the shape of this sprue and the pouring cup, then you can remove the sprue pin, because you do not need the sprue pin. Then you need an empty cavity for the liquid metal to flow. So once you've already formed it, you can remove the sprue pin. Yeah. Core is to create a hollow casting. If you want your casting to be hollow, you can use a core. Okay, so parting line is to separate the cope and drag. So normally in any manufacturing processes, due to high heat, high pressure, both cope and drag can just stick together and will refuse to be parted. So in those cases, you need to make sure that there is some kind of anti-stick powder, which we called anti-stick powder, which is being put on the parting line to prevent the cope and drag from sticking to each other. Okay, that's it for today, class. Thank you very much. I'll continue in the next lecture.